Okay, good morning, friends. Okay, so we'll continue the last problem. Uh, so I think how many steps we have covered? First two steps, three steps we have covered, I think. Okay, so design of beam. So we'll continue from step 4. Okay, so what is step 4? Design shear strength. Design shear strength for resistance. Design shear strength for resistance. It means we have to calculate VDR, design shear strength for resistance. It means we have to calculate VDR. Okay, so VDR is equal to, what is formula for VDR? Fy into AW divided by under root of 3 gamma m naught. So here we have to calculate AW. So AW is the H into TW. So H is the height of wave and TW is the thickness of wave. So H into TW. So which section we have selected? ISHB 400. So it means 400 into, what is the thickness of wave? TW. ISHB 350. Okay. So ISHB 350. So 350 is the high H and thickness of wave. Wave is 8.3. Okay. So tell me the AW, area of wave. AW is nothing but area of wave. So 350 into 8.3 is 2905. 2905 mm square. Now put the values, all values. VDR is equal to Fy is 250. Then AW is 2905 divided by under root of 3 gamma m naught is 1.1. So calculate VDR. VDR is the strength, shear strength. So strength is in kilonewton. So 381.18. 381.18 kilonewton is the shear strength registered by this selected section. So check for shear. Here we have to calculate check for shear. So check for shear is the VDR should be greater than VD. So VDR is here 381.18 and VD is how much? And second check is VD should be less than 0.6 VDR. So here VD 0.6 into 381.18. So how much VD value? VD is the 183. So VD is 183 kilonewton. So how much this value? 0.6 into 381. 0.6 into 381. Two 228.71. This is 228.71 and this is 180, means hence safe. This 381 is greater than 183 and this 183 less than 228. So whichever section provided by us, that section is safe for shear strength. It means shear strength will be carried by IS HB 350 is more than the shear force, design shear force. म्हणजे जो शियर फोर्स आपण डिझाईन केला 183 शियर फोर्स आपल्याला येणार आहे आपल्या मेंबरवरती, पण आपला जो सिलेक्ट ISHB 350 सिलेक्ट केला तो मेंबर 318 इतका लोड घेतोय, रेजिस्ट करतोय. 183 येणार ला डिझाईन केलंय आपण, डिझाईन लोड असणार आहे शियर फोर्स 183, पण घेणारा लोड आहे तो 384. म्हणजे आपण आपला सेक्शन सेफ आहे. वॉट एव्हर सेक्शन वी हॅव प्रोव्हाइडेड दॅट विल बी सेफ. फॉर दॅट वी हॅव टू टेक दिस चेक. So here shear strength is over. Now step number 5, design bending moment. Design bending moment for resistance. Design bending moment for resistance. So we have to calculate here MDR. But before calculation of MDR, we have to read the problem statement. Here the beam is given laterally unsupported. So for laterally unsupported beam, the formula of MDR is different. For laterally unsupported beam, what is formula for MDR? Please see the procedure now. Go back where procedure we have written. So formula is beta B into ZP into FCD instead of FY here. Sorry, FBD. FBD is given. So FBD divided by or only FBD. Okay, only FBD. Okay, so now here we have to calculate FBD first. So FBD, what is FBD? Again you have to see the formula, zeta LT into Fy divided by gamma m naught. So for that again we have to calculate zeta LT. So zeta LT is equal to, so this formula is we have to calculate. Zeta LT is equal to what? 1 divided by phi LT plus phi LT plus phi square LT minus lambda square LT raised to 5. Then in this formula we have to calculate again phi LT. So phi LT is equal to, say I am writing formulas. Phi LT is 0.5 in bracket 1 plus alpha LT in bracket lambda LT minus 0.2 plus lambda LT square. Then here how to take lambda LT, value of lambda LT as given in procedure. Lambda LT is equal to what? The given in the procedure. See, go back and see the procedure. The lambda LT, sorry, alpha LT value we have given. How much value of alpha LT? बघा कोणी तर पाठीमाग लिहून दिलेला आहे. For rolled section 0.21 for rolled section, correct? 0.21 for rolled section and 0.49 for welded section. Now we have used the section is rolled section. Directly steel table मधून आपण जो हा I section यूज केलाय तो welded section नाही, rolled section आहे. सो रोल्ड सेक्शन वी हॅव सिलेक्टेड. वेल्डेड म्हणजेच प्लेट, दोन प्लेट एकमेकाला अशा वेल्ड केलेले आहेत, पुढे आहेत वेल्डेड सेक्शन सुद्धा स्टील टेबलमध्ये. पण आपण चूज करताना कुठला सेक्शन कायम चूज करतो? रोल्ड सेक्शन. सो अल्फा एल टी वी हॅव टू यूज ऑलवेज 0.21 हियर. आर यू गेटिंग? Because alpha LT value is 0.21. Now we have to calculate again lambda LT. So one by one from bottom to top we will go. So again lambda LT. So how to calculate lambda LT? So this is very lengthy procedure. Lambda LT is equal to again beta B into ZP into Fy divided by MCR. So MCR is the elastic critical moment. So again we have to calculate here MCR. So MCR is equal to, now we will get this value MCR, pi square EIY HF divided by 2 LLT square in bracket 1 plus 1 by 20 in bracket LLT plus RY, sorry, LLT divided by RY divided by HF by TF, HF upon TF square. Now here we have to put these values for MCR. Okay, pi square into E. Have you written this formula MCR? Please write down this formula first. MCR is equal to under root of pi square E IY I will write here pi square EIYHF, pi square EIYHF divided by 2 LLT square in bracket 1 plus 1 by 20 LLT by RY divided by HF divided by TF square. So this formula is given in procedure. Now here what is E? Modulus of elasticity for steel is 2 into 10 raised to 5. Now I, moment of inertia for the selected section, IYY. Please again go to steel table. Whatever section we have selected, ISHB 350. What is moment of inertia about y-axis for this section? Please find the steel table. Whatever section yesterday we have selected, ISHB 350. See the IYY value. IXX we have written, IYY no, we have not written. So IYY value is here. What is IYY value? So IYY value is 2451. Please verify me. 2451.4 into 10 raised to 4. Is this correct? Someone can correct me. If this is correct, say yes or no. 2451.4 into 10 raised to. Okay, correct. Swapnil say yes. Okay. Now HF. How to calculate HF? As I had told you. HF. How to calculate HF? HF is the H minus TF. No? H minus TF. So H is 350 minus TF, thickness of flange. I am correct. HF is the H minus TF. I have written in the procedure, given in the procedure how to calculate HF. HF means what? Actually, this center to center, या फ्लॅनच्या सेंटर पासून या फ्लॅनच्या सेंटर पर्यंत आपल्याला HF आहे. ते कसं कॅल्क्युलेट करणार? कारण का टोटल H असतं, हे आहे TF. तर HF इज इक्वल टू H मधनं जर TF मायनस केलं तर आपल्याला HF मिळतं. सो आय हॅव गिवन नो दिस फॉर्म्युला, HF इज इक्वल टू H मायनस TF. इन द प्रोसिजर आय हॅव गिवन दिस. गो बॅक टू प्रोसिजर. तिथे एक पेज पाठीमागे पकडूनच ठेवा जिथं तुम्ही हे फॉर्म्युले लिहिलेत तिथं. So how much TF, thickness of flange? 11.6. Okay. Okay. 11.6 divided by 2 into LLT. What is LLT? I have told. What is LLT means what? Effective length of the effective length for lateral torsion. So effective length we have calculated. How much effective length was there? We have calculated effective length. 4.850 meter. Okay, but these all dimensions are in mm, so we have to convert into mm this. So 4850, correct, square, because LLT square, the formula is LLT square. So LLT is 4.850, so we have to make here square. Okay, now again bracket 1 plus 1 by 20, again LLT is again here 4850 divided by RYY. Please again go back in steel table. RY value we have to calculate here. Radius of gyration, RYY value of the section, selected section, ISHB 350. How much? RYY value 53.4, correct Sonali, 53.4. Others also please give me answers. For online examination, this is the very difficult subject for the online examination. Theory examination उलट पास व्हायला सोपं आहे, पण ऑनलाईन साठी सगळ्यात अवघड सब्जेक्ट हाच असणार आहे. आता एवढं सोपं काहीच विचारलं जाणार नाही तुम्हाला. मग त्याच्यासाठी खूप स्टडी करावं लागणार आहे. आता जे काही झालंय त्याचा प्रत्येक फॉर्म्युला पण पाठ पाहिजे, थिअरॉटिकल बॅकग्राऊंड सगळं असलं पाहिजे. ओके, सो डिवायडेड बाय HF by TF. HF by TF. So HF is we have calculated how much HF? This 350 minus 11.6. HF is 350 minus 11.6 divided by TF is again 11.6. Bracket, I think square. So now calculate MCR. MCR. Sorry. MCR. So MCR is in, because this is in movement. So kilonewton, sorry, Newton mm. Newton mm, because we have used here all dimensions in mm and Newton. So please do the calculations properly. Do the calculations properly and tell me answer. Over MCR in Newton mm. .05. Shraddha has given answer me 5.89 into 10 raised to 3. Here 20 point, please, one more. So three different students gave me three different answer. So which answer I should take? One more. Shraddha has given 5.89 into 10 raised to 3. Sonali 20.505 and Vaishnavi 22.72. One more person can give me answer. Swapnil, please verify the answer. Yes, Amol Pawar has given that 22.69. Oh, Swapnil 516.75 into 10 raised to 6. Okay, you were Vaishnavi and Amol answer matching, but other again, please do the calculations again properly. They have given here uh, miss do two answers. Swapnil, is this 22.73 is correct? You have did again 22.73 into 10 raised to 3. This answer I got from 3 students. Deshmukh 35 roll number 21. So see MCR 22.73. This answer I got from 3 students. So this may be because I don't have this problem. I have taken from the okay. Swapnil, okay, correct. So okay, ठीक है 22.73 into 10 raised to 3 Newton mm. Okay. So now put this MCR value in alpha LT. Go above. आता इथे या. Now put here. Beta B is 1. Okay. Correct, Sonali. Now you are correct. Beta B is again here 1 into ZP value. How much ZP value we have taken here? So now calculate lambda LT here. MCR झाला, आता वरती या लॅमडा LT ला. सो लॅमडा LT मध्ये आपल्याला MCR ची व्हॅल्यू पुट करायची आहे. सो बीटा बी, सो फर्स्ट बीटा बी इंटू ZP व्हॅल्यू. हाऊ मच ZP व्हॅल्यू वी हॅव कॅल्क्युलेटेड? सगळ्यात लास्ट कॅल्क्युलेट केलेली व्हॅल्यू कुठली आहे ZP ची? सेक्शन सिलेक्ट केल्यानंतरची. ZP रिक्वायर्ड घ्यायचं नाही. ZP इथं ZP रिक्वायर्ड घ्यायचा नाही, ZP अवेलेबल घ्यायचा आहे, जो आपण सगळ्यात शेवटी ZP कॅल्क्युलेट केला स्टेप नंबर 2 मध्ये. हाऊ मच दॅट ZP व्हॅल्यू इज हियर? प्लीज पुट 1248 बरोबर आहे. 1248.07 into 10 raised to 3. Okay. Into Fy is 250. Divided by MCR. Now here divided by MCR. So MCR is your 22.73 into 10 raised to 3. So calculate lambda LT. Use the root. Root miss करू नका. After calculation, put this value into root. Lambda LT. This 10 raised to 3, 10 raised to 3 get cancelled. Only do the calculation. This 1248 into 250 divided by 22.78. Here Newton get cancelled, then mm square get cancelled. So 117.16. 117.16. Okay, 117.16 is the lambda LT. So lambda have no unit. Lambda having no unit because slenderness ratio. आणि इथलं जर कॅल्क्युलेशन केलं तुम्ही न्यूटन एमएमचं तर हे दॅट एमएम स्क्वेअर अँड न्यूटन गेट कॅन्सल. ओके, because here mm square is here Newton per mm square, so mm square, this zp value is mm cube, that all get cancelled. Okay, so now put this lambda lt value here again into phi lt formula. See, phi lt formula is 0.5 in bracket 1 plus this alpha lt is 0.21, then lambda lt is 117.6 minus zero point 0.2, bracket complete, again lambda lt is 1.117.6 square. So tell me here phi lt, again phi lt having no unit because this is the again factor phi lt. I have given what is phi lt, what is lambda lt, each and everything I have given in the procedure. लॅम्बडा एल टी म्हणजे काय, फाय एल टी म्हणजे काय, अल्फा एल टी मीन्स व्हॉट. नाउ व्हॉट इज फाय एल टी? ओके, 0.5. This 0.5 in bracket 1 plus 21 in bracket 117.6 minus 0.2 plus 117.6 square. So how much this answer? 6.98 into 10 raised to 3. Others please. Anyone other? 6.87 into 10 raised to 3. Okay, but ठीक है, 6.98 into 10 raised to 3 is the phi lt. Okay, okay, 87. Here is the 87 answer. Okay. Now put this phi lt into zeta here, 1 upon phi lt is here 6.87 into 10 raised to 3. ही व्हॅल्यू आता झिटा मध्ये पुट कर, झिटा एल टी मध्ये पुट करायची. सो 6.87 into 10 raised to 3 square minus 10 raised to 3 bracket square minus LLT is 117.6, sorry, lambda LT square bracket complete raised to 0.5. Now again calculate this 6.87 into 10 raised to 3 plus 6.87 into 10 raised to 3 square minus 117.6 square raised to 0.5. Raised to 0.5 means under root of this. Tell me answer of